Hello students, in this lecture we are going to discuss the Vsepr theory, second part, Vsepr theory second part. Now, but before discussing the second point of the Vsepr theory, we will discuss some ionic compounds which have only bonding electron pairs and not any non-bonding electron pairs. So these types of molecules are PO4 3 negative, second is SO4 2 negative, this is phosphate, this is sulfate, and third we have NO3 negative, this is nitrate. Now let's discuss their shape. So we know that phosphorus have 5 valence electrons because it belongs to nitrogen family, nitrogen, phosphorus, arsenic, antimony and bismuth. So this is the family of phosphorus. So phosphorus have 5 valence electron. Now in PO4 3 negative we have 3 electrons come from outside. So if we made pairs, then we have four pairs. So phosphorus, here one pair, here one pair, here one pair, 4 pairs. So total 8 electron, 5 valence electron plus 3 electron phosphorus gained from outside. Now as we know, the oxygen forms double bond. So here we have 4 double bond. Now this is the molecule. So as we know, it looks like only 4 bond pairs. So as we know, when the molecule have 4 bond pair, then the hybridization is sp3 and the shape of the molecule is tetrahedral. So PO4 3 negative have tetrahedral shape like this. This is the geometry of the PO4 3 negative. In the similar way, we know that the sulfur have 6 atoms, 6 valence electrons and 2 electron it gains. As we know, NSO4 2 negative, it gains 2 electrons, so 2 electrons again. Now SO4 4 oxygen bonded with sulfur, so in this way the 4 oxygen is bonded with sulfur. Now as we see here one double bond acts as a 1 bond pair. So 1 2 3 4, so here 4 bond pairs are present. So as we know that for counting hybridization we will count only, for example in SO4 2 negative we count only sigma bonds. So here 1 sigma 1 pi, 1 sigma 1 pi, so 4 1 sigma, 2 sigma, 3 sigma and 4 sigma. So 4 sigma bonds are present, so hybridization is sp3. Now sp3 hybridization with no lone pairs have tetrahedral shape, as we discussed in the previous video, and the link of the previous video is given in the description box. You will go and first see the part first of Vsepr theory. So in this way SO4 2 negative have also tetrahedral shape. Now let's discuss the shape of NO3 negative. So what is the shape of NO3 negative? So in nitrogen, we know that nitrogen have 5 valence electrons. 5 valence electron. So here we have nitrogen. It have 5 valence electron, and in NO3 negative it gains 1 electron, so 6 valence electron. Now nitrogen forms the join with the 3 oxygen. So 3 double bonds we have because oxygen form double bonds only. So in this way 3 double bonds, and here nitrogen does not have any lone pair. So the shape of the nitrogen NO3 negative nitrate will be 3 bond pairs only. Then the 3 bond pairs only form the 1 sigma bonds, and again 1 sigma, 3 sigma bonds. So hybridization is sp2 and the shape of the molecule is trigonal planar, as we discussed in our previous chart. So I again tell you, please go to the previous video which is given in the description box, whose link is given in the description box, and please firstly see the previous video of Vsepr theory and then come to this video. Now we are going to discuss the second point of Vsepr theory. So rule second. In previous video we will discuss rule rule first. Now rule second. If the central atom, suppose we have A, B, N type of molecule here. A is the central atom. If the central atom is surrounded by bonding as well as plus non-bonding electron pairs. Central atom is surrounded by bonding plus non-bonding electron pair. Then the symmetry of the molecule is not regular. And it have distorted symmetry. Distorted. Here it is D. Distorted symmetry. Molecule have distorted symmetry. The distorted symmetry is mainly due to the presence of non-bonding electron pairs. And this distortion is caused by non-bonding electron pairs, that is lone pairs. This distortion is caused by the lone pairs. Now, as we know, the lone pair repulsion is greater than the lone pair bond pair repulsion is greater than the bond pair repulsion. So due to the lone pair, the distortion in the symmetry of the molecule is caused. Now let's discuss how the distortion in the symmetry is caused. So take the example of 3 molecules, CH4, NH3 and H2O. How the lone pair causes distortion in symmetry. So this is H2O, this is NH3 and this is CH4. Now as we know that the CH4 have the symmetry of tetrahedral and it have bond angle 109 degree and 28 minutes. Now here NH3, as we know, it have one lone pair. So if NH3 does not have lone pair, then its shape is like this. Let's make it clear. So here N, here one lone pair, here bond pairs. So this is NH3, and in NH3 we know that the angle between bonds, this is not the angle. The angle between the bond pairs is 107 degree, approximately 107 degree. So with increase in one lone pair, here no lone pair, here one lone pair, so bond angle decreases by approximately 2 degrees. Now on going from this NH3 to H2O, we are taking example. Now we will discuss, and here the angle is 104.5 degree. So again the bond angle decreases by approximately 2.5 degree. So with increase in one lone pair, here are two lone pairs. So here angle decreases by again 2.5 degree, and the angle will be 104.5 degree. So in this way, with increase in the lone pair, the bond angle decreases by approximately 2 to 2.5 degree. Now let's discuss how the symmetry of the molecule changes by lone pairs in the molecule. So here we have CH4 molecule, and here we have NH3. So if we make one bond is made by two electrons, so if for instance we take these lone pairs as the bond pairs, then the symmetry of the molecule is tetrahedral. Now as we know, the lone pairs does not act as bond, so this will come at the top like this. So the geometry of the molecule is pyramidal symmetry. Pyramidal symmetry we have. Now let's discuss the symmetry of the I3 negative. So what will be the shape of I3 negative? So firstly take lone pairs as the bond pairs. We have two I atoms. As we know, the I have I3 negative. So how many atoms I have? We know I have 7 atoms plus one lone pair is equal to total 7 electrons in the valence shell and one lone pair. One electron it gains. Here we have minus sign, so total 8 electrons I have. So in this way, one electron form bond with one I, another electron form bond with another I. Now we have remaining 6 electrons, so one lone pair here, one lone pair here, and one lone pair here. So in this way we have, if all these lone pairs form bonds, then the symmetry of the molecule is trigonal bipyramidal. But as we know, this molecule has symmetry. This lone pair does not form bonds. So we will deal this lone pair and erase these bonds and make the lone pair as. So in this way, the symmetry of the molecule is linear. So if these electrons form bonds, then the symmetry of the molecule is trigonal bipyramidal. But when the lone pair comes, the lone pair is present, then the symmetry of the molecule is linear. In this way, the symmetry of the molecule is disturbed by the presence of lone pair. In the similar way, we have I3 positive. How I3 positive? Symmetry is affected by the lone pair. Let's discuss. So we have I3 positive. So I3 positive, as we know, I have 7 electrons in the valence shell, that is iodine, and here one positive charge means one electron is removed. So total 6 electron is present. Now as we know, if we have 8 electrons in the valence shell, then we have 4 bonds is formed. So if 4 bonds, then the sp3 hybridization and the shape is tetrahedral. So let's make lone pair one side and I atoms present like this. But these are lone pairs and these are not bond pairs. So erase these bonds. Erase these bonds and these are lone pairs. These are lone pairs. So what comes? The shape of the molecule is bent shape. Bent shape, and it is like H2O, because H2O have also two lone pairs and two bond pairs. So in this way the geometry of the molecule changes with the presence of lone pairs. So this is the second rule, that when the central atom have valence, have bond pair as well as non-bonding electrons, bond pairs as well as lone pairs, then the geometry of the molecule is distorted. In this way we will discuss the second rule for the Vsepr theory. Thank you very much. Now in the next lecture we will discuss the third rule. Thank you very much, and please subscribe my channel, and please like, subscribe and share my channel. Thank you very much.